Hi, Steve Lott from Team Red here explaining why Red Ranger sucks so bad at sailing. The situation is like this. We're always trying to go from here to there directly into the wind, and for the purposes of our diagram, the distance we're trying to cover is D. It could be a couple of nautical miles, it could be a couple hundred nautical miles. The usual rule of thumb for most sailboats is they can tack through 45 degrees. They go 45 degrees off the wind, and then they turn the boat and they go 45 degrees off the wind in the other direction. Obviously, they're going to sail further. What's the distance they wind up sailing? Well, there's a Pythagorean theorem that explains what that distance is going to be. And it turns out that with a little bit of math, we can figure out that they go 41% further. But what this means is that if you're powering into the wind with Mr. Lehman thundering away below decks at 4 knots, if you fall off and try to sail, you've got to make 5.6 knots under sail in order for it to really be worthwhile. If you just continue to muscle into the wind, you might actually get there sooner rather than sailing. And of course, Red Ranger is not a simple boat that tacks at 45 degrees. Red Ranger tacks through 60 degrees. What's the total distance sailed in Red Ranger? Well, it's an equilateral triangle. All 3 sides are the same length. In order for us to beat to weather under sail, we have to sail twice as far as we would have motored. And that means that we have to somehow, when we pull out the sails, go twice as fast. So, oh, by the way, what if you don't have a boat like Red Ranger? What is your distance covered going to turn out to be for your unique tack angle? Maybe you're a high-speed super race boat that can tack through 30 degrees, or maybe you're some boat even doggier than Red Ranger and tack through more than 60 degrees. Turns out that there's 2 symmetric triangles here, from here out to where you're going to tack, and from where you're going to tack to there. And the angle T, there is your tack angle, and it turns out there's this middle of the triangles, the furthest away you're going to get from the direct line, what the sailors call the rum line. The height of that is h, and the total distance, it turns out, is a function defined by the mathematicians called secant. And so the distance sailed is basically your rum line times the secant of your tack angle. And to save you having to figure out where the secant button is on your iPhone calculator, here is the way it works out, that if you can tack through 40 degrees, you need to go 31% faster than your motoring speed. And so if you were motoring into the wind at 4 knots, you need to sail at 5.2 to make sailing faster than motoring. And you'll notice when we get down to Red Ranger with its tack angle of 60 some odd degrees, speed has got to double or it's not really worthwhile putting up the sails. Doesn't mean it's not completely not worthwhile, but it means that you're not going to go any faster. The difference with sails beating to weather like this is that you tend to use less fuel. You just don't go any faster. So from the usual perspective of how fast can we go, the boat only goes through the water at a little over 7 knots. So if we are bashing into the wind at 3.5 knots or more, that's really the best we can possibly do, speed-wise. And falling off is never going to get us all the way past 7 knots, and because the hull can't go through the water that fast, and so there's no point in sailing. We might as well just motor. So we suck at sailing because we can't point the boat high enough. Our tack angle is a pretty shabby 60 degrees, and that's a combination of boat rig and skill issues. It's a big old Whitby, it has saggy old sails, and we are newbies at sailing. We're not quite sure what we're doing yet. A real sailboat looks like this, a flat mainsail. Between the bottom and the top of the sail, there's very little twist. You can see that the top is turned slightly away from the direction the boom is pointed, but not much. Their jib is sheeted almost right in the middle of the boat. There's a very narrow slot between the jib and the main. Red Ranger looks like this. The mainsail is baggy. The top has a huge amount of twist relative to the bottom of the sail. Yes, our mizzen is crooked and leans aft, and our jib is not down at the foredeck. It's got a very high foot, and it only sheets down to the rail, no closer than that. So this is why we spend a lot of time motoring in Red Ranger, and when we sail, we mostly sail for fun, not to get somewhere. It's not a bad thing. That's just the way she is. This is Steve Lott from Red Ranger saying, have a great time. We wish you were here too.